Okay, so we're going to talk about lesson 7.1, angles of polygons. And our essential question is, what is the sum of the measures of the interior angles of the polygons? And how do we use the interior angles and exterior angles to find different measurements? So this is the beginning of a chapter, so you can see there is quite a bit of new vocabulary here: diagonal, equilateral polygon, equiangular polygon, and regular polygon. So we'll be going through those. So let's start off with just a diagonal. A diagonal is the connection of two non-consecutive vertices. So if you take a picture like the one here and you create a diagonal, you're just going from one vertex to the next. And you can do that with all of your figures that you have here. So go ahead and take a second and create those triangles. I almost created one there that I didn't need to. But go ahead in a second and create those triangles, because what we do know is that triangles are equal to 180 degrees, always. So once I count the triangles, I can derive the formula that helps me figure out exactly how many degrees are in a figure for the interior angles. Notice every single time I'm starting from one vertex. Okay, so once you do that, you count your triangles. There's one triangle and there's two triangles. So that's all I'm doing, is counting the number of triangles. Two triangles. This one has 1, 2, and 3. So that's 3 triangles. 1, 2, 3, 4, 5, and 6 triangles. And how many degrees are in each triangle? Well, 180. So if you multiply that by 180, you will actually figure out, oops, I forgot my 0. You'll actually figure out how many degrees are in a figure. So for example, this one is 360 degrees, 540 degrees, 720 degrees, 900 degrees. Almost forgot my extra 0 there. Something about me and zeros today, huh? And 1080. And that's how many degrees are total in the figure. So if you add up all 4 angles here, 360 degrees. If you add up all 5 angles here, 540 degrees. So that's basically what it means to have that. So then take a look at this and say, well, this has 1, 2, 3, 4 sides and 2 triangles. This has 5 sides and 3 triangles, 6 sides and 4 triangles. And every single time you should notice that you're taking the number of sides minus 2, and that equals your number of triangles. So in the end, you end up deriving this formula. It's actually right here. You take the number of sides minus 2 and multiply it by 180. So for example, this is 7 sides. 7 minus 2 is 5, times 180 is 900 degrees. So that's how we figure out how many degrees are in a figure. And if you take a look at this, I can say there's 1, 2, 3, 4 sides. So 4 minus 2 times 180 gives me 360 degrees. So now that I know that, I can solve for the missing angle here, because I have 108 plus 121 plus 59 plus x equals 360. So that's x plus 288 equals 360. And so x is going to equal 72 degrees. Kind of slick, right? That was an 8, by the way. It doesn't look like an 8, but it was. So this is a coin of Canada. I think it's called a loonie, but it's actually 11-sided. So you take 11 minus 2 times 180, and you're going to get 9 times 180, which is 1620. That's how many degrees are on the inside of this figure. So that's the sum of the measure of the interior angles. Now, the sum of the measures of interior angles of a convex polygon is 900. Okay, I can use this formula forwards and backwards. And what I mean by that is I can say n minus 2 times 180 equals 900. I can divide by 180 on both sides, which leaves me n minus 2 equals 5. Add 2, n equals 7, and I realize this is a heptagon. Hepta means 7. Okay, same type of thing here. Looking for the interior angles. First of all, figure out how many angles you have. And this is a quadrilateral, so that's 360 degrees. So x plus 3x plus 5x plus 7x equals 360. You get 16x equals 360, and x equals 22.5. So your angle measurements are 22.5 degrees, 67.5 degrees, 112.5 degrees, and 157.5 degrees. It asked you to find the measures of all the interior angles. So that's what we did. The sum of the measures of the interior angles of a convex polygon. Convex is really key here because convex means it's all poofed out, no cave-ins, right? So I can use that formula, n minus 2 times 180 equals 1440. Again, divide by the 180. You're moving things away from this, so that's why you want to get rid of that. N minus 2 equals 8. So add 2, and n equals 10. And this figure is called a decagon. Okay, flip the paper. So some more vocab terms that we were going to learn. An equilateral polygon means that all the sides are congruent in the polygon. Equiangular means all the angles are equal. And regular means both is true. They're equilateral and equiangular, and most of the time that's what we'll be working with. So for example, a home plate for a baseball field is shown. Is the polygon regular? Explain your reasoning. Well, if you take a look at this, you can actually see 90, 90, 90, and I don't know what. So no, it's not regular because no, not equiangular. So then find the measures of C and E. Well, I don't have anything there, so I'm just going to call it X and X. I know they're the same because they're marked that way. So I end up with 2x plus 90 plus 90 plus 90 equals, and how many degrees are inside of a pentagon? Remember, that's 540. You can look at the front page if you want to for that. So equals 540. So you get 2x plus 270 equals 540. And by the time you're done solving that two-step equation, you get x equals 135. So this is 90, 90, 90, 135, 135, and that should all equal 540 if you check your work. Same type of thing on this other one. If you're finding the measurement of angle S and the measurement of angle T in the diagram, all you have to do, figure out that this is all 540 degrees, call this x, or any of your favorite variables, doesn't matter, and you get 93, no, let's say 2x, plus 93 plus 156 plus 85 equals 540. So 2x plus 334 equals 540. When you are done solving for this two-step problem, you get that it's 103 degrees. Okay, something you need to mention about exterior angles. The exterior angles of any polygon, doesn't matter how many sides it has at all, ever. But the exterior angles of any polygon are always 360 degrees. So remember, the word sum means add. So they always add up to 360 degrees. always. So it doesn't matter how many angles I have. It could be 5, it could be 10, it could be 6, it could be 4. They will always add up to 360 degrees. Makes it kind of easy for exterior angles, I have to say. So let's take a look at this trampoline. We're going to do a couple things with it. So the trampoline is 12 sides. Find the measure of each interior angle. Each. Keyword here you need to pay attention to. So if I'm finding each angle, then what I'm doing is I'm taking 12 minus 2 times 180, and then I'm dividing that among the 12 angles. So you end up with 90 degrees each. So the reason I'm dividing by 12, once I find the total of the angles, which is 1080, I divide that by 12 for each angle. So to find the measure of each exterior angle, you need to remember what I literally just said a few seconds ago. There are 360 degrees in the exterior of any polygon. There's 12 angles I need to account for. So that's 30 degrees for each exterior angle. Here's another exterior one. So this is x plus 2x, so 2x plus x plus 67 plus 89 equals 360. So 3x plus 156 equals 360. 3x equals 204. And then x ends up equaling 68. So this is 68 degrees, and this is 136 degrees. And if you want to check your work, which I always recommend, but 136 plus 68 plus 67 plus 89 should equal 360 degrees. Try it again. This is 1, 2, 3, 4 sides, but that doesn't matter because I'm looking at exterior angles. So 4x plus 98 plus x plus 162 equals 360. So you get 5x plus 260 equals 360. 5x equals 100, and x equals 20. So this is 80 degrees, and this is 20 degrees. Last one for these examples. A convex hexagon has the measures of 34, 49, 58, 67, and 75. Remember that a hexagon is 6 sides. So what is the measure of the exterior angle for the 6th vertex? So I just need to add all these up, and I'm going to get the 6th vertex plus the 283 degrees that I already know that I have from adding these up. 34 plus 49 plus 58 plus 67 plus 75 is 283. So my last one is going to be 77 degrees. So I have 5 angles that I already knew, and the one that I didn't. That accounts for all 6 angles in a hexagon. Hopefully this helped. If you have any other questions, please let me know. For some of you, this could be a review. For some of you, this might be the first time you heard this lesson, but let me know either way, and I will talk to you guys later.